So my second month here, back in August of 2022, I saw my first example of a hickory with clubbed branch ends that didn't have any like foliage on the branches. It seemed like this like really obvious set of symptoms that should be really easy to figure out what it is. And so I started doing some like Google searching, looking at NC State materials, and couldn't find anything. Found some things that like looked vaguely like it. So I ended up taking a bunch of photos and sending them into Matt Jones of the NC State, I can't remember which office he is, but he's one of the horticulture extension agents, and gave him kind of what I thought it could be. And he's like, yeah, it's definitely not those things, but he didn't really have an answer. And so it sort of passed out of mind for a while, and then I saw a second one, and so I went back and I was like, this is like, it's such a distinct feature. You can kind of see it here. Do you see all of these like swollen nodules like within the tree? There's some clubbed off ends. Sometimes the swelling will happen sort of mid-branch, but it was really these like clubbed ends that perplexed me. Because a lot of times it didn't even seem like the branches were necessarily dead. And so eventually I reached out to Larry Ekert, who used to be with Leaf and Limb, who's kind of the plant pathology wizard in this area, and he didn't really have an idea of what it was. And it just really bothered me. And so finally, I saw another example earlier this year, and then I was like, I just need to get up into a tree. Oh, and I had found some of these on the ground below a tree that one of our crews had removed and left the wood on site. I took a bunch of these clubs home, cut them down the middle with the chainsaw, popped them open, and oftentimes, or not oftentimes, in each case, there would be like decay kind of like in the center. And so I assumed it had something to do with like a fungus, and it was creating these, and this one doesn't have it. There was an odd mix of, some would have these kind of cankers like you see here, but then this one was more or less intact with maybe like a couple holes. And so I thought maybe a bug is burrowing into the wood with a fungus, similar to what like ambrosia beetle or a pine bark beetle does. And that could be the mechanism. But again, I couldn't find anything online that addressed this like really freaking obvious set of symptoms, which I found really perplexing. I couldn't have been the first person to notice this. In fact, both David and Craig, when I asked them about it, it said, yeah, we see this on hickories periodically. And so I reached out to David and asked if he had any on his property, and he did. And so I wanted to get up into a tree instead of just like looking at these after they'd already fallen onto the ground. And then I was going to cut them and then actually send in samples to NC State. And so this is sort of David in the, not sort of, this is David in the canopy as we're cutting them out. This was a tree on his yard, and just thinking about like what causes, in my head I was thinking of these as galls. And galls can mean any number of things, and they can be caused by a number of different inciting events: bacteria, fungi, nematodes, different insects, including aphids, midges, and wasps. There can be foliar galls, as we see with the elm finger gall on the left there. You can see stem galls. Some of them can be quite large in the case of like bacterial crown gall. And then you have some really, really funny looking ones like this pine oak gall rust, which occurs on pines. It's a pathogen that jumps back and forth between oaks and pines and creates some really bizarre looking galls. And a lot of different parts of a tree can be affected: leaves, twigs, roots, and flowers. But none of that information really helped me to figure out what was going on with this hickory. And so got up into the tree, climbed it, started taking a closer look, and there was one piece of critical information that kind of unlocked this, that we just needed to get up into the upper canopy to find. So I'm gonna pass these around so you can take a look at these. Have you guys been in a hickory with this? Mm-hmm. Yeah, does anyone, don't say it just in case, but does anyone kind of like have an idea of what this might be? Mm-hmm. All right, so I should have asked you. So pass these around. There's one that's been cut in half, so you can kind of check that out. Now, I had been wondering for over a year and a half what this was. So this was incredibly satisfying to finally figure it out. So I'm taking a photo in this photo of this. Yeah. So you guys that are nodding your heads, like what is this? Mistletoe. Phoradendron leucarpum. This is, so in the southeast, mistletoe only or in the eastern United States, mistletoe only occurs on angiosperms, broadleaf trees. But in the West, we also have dwarf mistletoes that also occur on pines. And if you'll notice, these little bits of oppositely arranged leaves and photosynthetic stem tissue are arising from a bulge. So here you can see it a little bit better on the left. This still isn't the clubbed branch end that I found really intriguing, but we're going to get to that in a moment. So we can see these aerial shoots arising from these bulges. The middle photo is the flower, is the plant in fruit. And it's fruiting right now, but they are dioecious. Does anyone want to remind me? I've been over like 4 different presents.
2 houses.
2 houses, yeah. So male and female parts are going to be occurring on distinct plants, and that means that the fruit of mistletoe will also not occur on every single mistletoe kind of outcrop that you find. And then on the right, they eventually, once they're old enough, they'll start to form these kind of globose-globular, round bundles of plant material, typically higher up in the canopy where there's more access to sunlight. And then you'll find these more meager showings a little bit lower in the canopy. And I think that also helps to explain why I was missing that critical bit of information like early on, because I was looking at branches that either died and already fallen, or I was seeing what was visible in the lower canopy, where maybe there was mistletoe at some point in the tree's past, because this is something that will live with the tree for a very extended period of time. And we'll get a little bit more into that in a moment. In fact, sometimes you'll find mistletoe like on the main trunk, or like really close to the trunk on really large scaffold branches. And mistletoe, when it's first getting established, is typically going to be getting established on younger, smaller shoots where the bark is still relatively thin. And we'll get to that in a second, is why that is. And then there's some funny names that kind of go along with this. So Phoradendron, the etymology of the Latin breaks down to essentially tree thief, and that gets to the parasitic life cycle of the plant. It's not fully parasitic. We call that in botany hemiparasitism. So it's semi-parasitic. So it is photosynthesizing. It's producing some of what it needs to survive, but it's tapping into the sap-conducting elements of the tree, the xylem, in order to get water, minerals, and then there are some other compounds that it's getting as well. And it is an obligate parasite, meaning it can't grow freely. It has to be attached to a host. Like in the case of certain parasitic fungi, they might be parasitic, or they may just be decaying deadwood, depending on like what the situation is. But in this case, they are always parasitic. I think of like the neighbor. You don't put a Wi-Fi, or you don't put a password on your Wi-Fi, and your neighbor like logs into it, and then they start torrenting or something, and it dramatically decreases your own bandwidth. That's essentially what this plant is doing. So it's siphoning off the energy of this tree, and during times of stress, particularly drought stress, when the tree is experiencing a water deficit anyways, the additional pressure that mistletoe puts on the tree can actually cause a tree to decline, especially if there is a widespread infestation. And with some of these hickories, I've seen it where it's almost like every single branch. And for some reason, I've only seen this kind of clubbed branch feature on hickories. I've seen pictures of it on other trees, but in this area, it appears to me if someone has experience with something else, yeah, it always seems to be a hickory. So there may be some interesting interaction there. So getting into its life cycle, so it is spread by birds. Some mammals like opossums will eat it as well, but birds are the primary spread of mechanism. Birds also are the primary spreaders of invasive plants. So I think we should just get rid of birds with the solution there. Don't tell the Audubon Society. Yeah, birds aren't real. So the birds eat the seed. It digests the pulp, but then the seed remains intact. And there's still a very sticky coating on the seed, and then there are also these kind of hair-like appendages on the seed. So when they excrete, when they poop it out, and it lands in a favorable spot, the seed will glue itself to the branch by virtue of that sticky coating and then these hair-like threads. And then it will grow what's called a radicle, which is like the earliest root that sprouts from the seed, and that presses itself against the tree branch. And then from the radicle, I'm just kind of sharing this to give you an appreciation of how complex this life cycle is. But something called the primary haustorium forms, which is a modified root that will actually penetrate a weak spot in the bark, like a lenticel, or maybe between a bud and a branch, like at an axillary bud. And it will then send out what are called cortical haustorium, which are it's a system of like radiating branches that from there produces these wedges that spike themselves down into the conducting tissues, all the way even until like the earliest growth increment. And and then the parenchyma cells in these wedges will actually fuse to the xylem, to the conducting vessels, and that's how they start siphoning off water by virtue of the fact that the aerial shoots are transpiring, which if you remember from our last discussion, that creates this negative sucking pressure. And so that's kind of like the mechanism by which these things get started. And typically, the root system takes a while to develop before you'll see these aerial shoots. And kind of a callback to our last lesson as well, the root system is considered endophytic, meaning it will live interior to the plant without causing a lot of damage. And so once the aerial shoots have formed and some time has passed, it'll start reproducing and the cycle continues anew. Now, what trees are going to be affected by mistletoe primarily? Because birds are the main mechanism of dispersal, you're going to find mistletoe in trees that birds like to perch in. So oftentimes those are going to be the tallest trees, especially because that's where mistletoe will have not only will that be where birds are perching, kind of in the upper canopy, but that's also where the mistletoe will have the greatest amount of sunlight to get going. Because they're hemiparasitic, not fully parasitic, so they do need to photosynthesize, but the root system can persist without the aerial shoots for quite a long time. So does it need to be managed? That really depends. If there is a very widespread infestation, it might already be kind of like too late to manage, because your management options are typically going to be like fairly expensive and tedious, or possibly very hard on the tree. So those management options would be removing the aerial shoots, which, because that root system is going to persist even without the roots, it has that endophytic part of its life cycle. What you are doing is essentially reducing the water, the stress that it's putting on the water needs of the tree. So once you remove the aerial shoots, it's no longer transpiring, it's not pulling water from the tree's xylem, but it will resprout eventually. And so it's just a temporary thing. So you can, the most kind of long-term way to manage it would be to remove the mistletoe, typically 6 inches past the point where you're seeing the aerial shoots. However, if a tree has a huge infestation, the stress that you put the tree under by removing like all of those sections of branches could be greater than the stress being put on the tree by the mistletoe itself. So that would maybe only be preferable if there's only like 1 or 2 branches and you're not putting like, massive diameter cuts close to the stem on the tree. Then the last option would be chemical control. There's a product called Florel. The name of the chemical is Ethifon. I haven't heard that said before, so that could be wrong. It's essentially like a growth regulator that you spray on each individual outcropping of the mistletoe. So again, super tedious. It's going to be expensive to apply. And that gives you 1 to 3 years of control. So not fully, not a final solution. That was a bad choice of words. But some things to consider. So what, kind of getting back to this club nature, does anyone have an idea of what might produce this like clubbed end where you're not seeing a branch? So there is an example, yeah, thank you. So you can kind of see the end of this, it's fairly smooth. Originally, there would have been a branch section that extended beyond past this. Did anyone have a guess, like what happened?
Truncate? I'm guessing the tree cut itself off.
Yeah, pretty much. Essentially, the mistletoe is siphoning off water, and so during periods of heightened water needs, so during periods of like drought or high heat, there's going to be a loss of water beyond the point as the mistletoe is siphoning off, and so there's going to be a natural dieback, or what's the word I'm looking for? A stunting of the growth beyond this point, and it will die back to the point where the mistletoe is. And then the tree, the reason why we have this kind of elliptical swelling is the tree is rapidly trying to produce new tissue to conduct water beyond the layers that the mistletoe is tapped into. Interestingly, the annual extension of those sinkers that I mentioned, these roots, the mistletoe syncs it up with the timing of the secondary growth on the tree. So as the tree is putting on new tissues, the sinker is developing with that, so it kind of floats on top of that. and that's how we get these. That's how we get those swellings. So I've got an actual example here. You can see this is a younger one, and it doesn't mean that there is no active mistletoe on this. This could have been lower in the canopy, but sometimes you'll see a tree that maybe hasn't had mistletoe for a long time, and then all of a sudden it sprouts it because of that endophytic nature of the root system. It can persist for some time without any leafy parts to sustain it. And so here, we have just a small little bud there, but this is not likely the first time that this spot has produced plant tissue, just because of how developed that little node, that swollen node is. Now, mistletoe is a native plant, and it's ecologically important. It fruits in the winter, and it fruits berries, and birds love berries. That is one of their preferred food sources, and so it's producing food for forage at a critical time of year when there's not a lot of other stuff to eat. Have you guys ever seen, I see it a lot around willow oaks in particular, where there's like a little juniper that's sprouted up right from the base. You see it pretty often. Any ideas? It's kind of a similar mechanism to this. What's going on there? What's that? Yeah, but why would it be happening, why is it so consistently at the base of it? In fact, this hickory that I'm in right there, you can't see it in the photo, but there is a juniper growing right at the base of the tree. So cedar waxwings in particular, they love both mistletoe and the juniper berries. They're cones, but they have a fleshy outer covering. And then as they're hanging out in the trees with mistletoe, or just hanging out in trees they like to hang out in, typically like a large spreading shade tree, they poop out those seeds. The tree is siphoning water down its stem during the winter. If you think about the way rain would run down the stem, and so there's going to be a higher concentration of water around the base of the tree, a great place for a new tree to get its start. So that's why you'll sometimes see those cedars growing directly at the base of these larger trees. And then also so to speak to why we are so consistently seeing decayed wood within those galls, over the long relationship that mistletoe will have with the tree, there are openings that are created as these stems are kind of dying back, and all of these become entry points for insects and fungi. So the decay is not directly related to the mistletoe, but it's creating opportunities for other things to get into these sections. And the branches will become weakened over time. So if you're seeing these over a parking area, it's a great pruning decision to maybe remove some of those. And in times of high stress, if these infestations are large enough, it can actually cause a tree to decline. And I think I've seen a few trees where the symptoms were progressed enough that even in just the last 2 years, we've had some really hot, dry periods. These are going to be really stressful pressures on the tree. And just kind of as a point of interest, there are a number of other parasitic plants in this area. And all of these here are fully parasitic, so they don't contain any chlorophyll. There's nothing green about them. They're getting everything they need from either mycorrhizae, in the case of these ghost pipes. In fact, that photo comes from Craig's brother's property, where he found those. Those are related to blueberries. They don't produce any chlorophyll. I think commonly called ghost pipes. It's Monoflora or Monotropa uniflora. These are really fun. You've almost certainly seen these. These are beech drops. They tap the roots of beeches. They do not photosynthesize. And they're, from what I've read from NC State, they're actually a sign of like a well-functioning forest. So neither of these are like of any concern to see. And then on the right, this really odd-looking one, this is bearcorn. It'll tap the roots of oak and beech and produce these like lumpy nodules, somewhat similar to the galls on the hickory from the mistletoe. And you'll see these, I've only seen them in winter, but yeah, any questions about, so kind of a general survey of parasitic plants in this area?
You mentioned that what was the foliage called for the mistletoe?
Oh, these aerial shoots?
Aerial shoots.
Yeah.
So the aerial shoots will grow back sometimes. What causes them? Do they just get mechanically knocked off during the winter?
Yeah, so they're really great question. So Michael asked, like, why might they grow back? Like, what has caused them to, correct me if I'm...
Go away, yeah.
Yeah, what causes them to go away? Now, they're really brittle. So you're thinking like an ice storm or a windstorm. And I think I read they typically persist for anywhere from like 3 to 5 years. But they're really easy to snap off. Like this tree is not, or this plant is not putting a lot of energy into creating like a really durable structure. And so it doesn't really need to be super, it's not trying to produce something that's going to last like decades. And then, it does have parenchyma cells, so it does have, and interestingly, so it will store some of what it's photosynthesizing within its own tissues. If you remember back to your, like studying for your ISA, parenchyma cells, that's one of their function, is storage. But this relationship doesn't go both ways. They're not transferring some of those photosynthates it's producing like back to the tree. It's all take, baby. I didn't finish my thought. So this wood within these galls, it becomes decayed, and then a certain type of woodpecker called a flicker, if they're large enough, and these clubs can get quite large. Like David and I saw one in this tree that, I don't know, it was like this big around. I wish I had brought it. The birds will use the softened wood to create cavities. Like I said, I saw flickers mentioned in particular. And then after that cavity has been made, like other, like secondary nesters will come in and use it afterwards, like certain types of owls. Has anyone seen these clubs and wondered what they were? Did you know that the mistletoe caused these swellings?
I mean, you often see them together, so you can kind of...
Yeah, deduce. I literally, in this massive tome, the Disease of Plants and Trees manual, it's such a distinctive feature. I went through page by flipping page to find a picture of the symptom, because like everything is in this book. And they have a discussion of it, but the photo doesn't really show like the thing that I was noticing. So anyways, a year and a half of scratching my head, finally got the answer this weekend, and it was super satisfying. So any other questions? All right.
Thanks, Dave.
That was excellent.